So welcome to our webinar on public EV charging units, how to design for accessibility. We are Designability. Designability is a national charity that enables disabled people to live with greater independence. For over 50 years, we have used human-centered design to create products with and for disabled adults and children to improve and enrich their lives, giving them greater choice every day. Let me introduce you to our speakers today. Hazel Boyd is our user experience researcher at Designability. You should be able to see Hazel now. Hazel worked directly with disabled people and those close to them. The results of this research fed directly into the design work, which we're going to take you through, and subsequent design guidance. Hazel also sat on the steering group for the BSI standard, and we will say something about that later in the webinar. Keir Haines is our senior product designer at Designability. Keir led the design guidance process and delivery for Designability while also sitting on the steering group for the BSI standard. And I'm now going to hand over to Keir.
Thank you, Jack. Good morning. Oh, good day, given it's just gone past midday, everybody. Thank you for coming along today. As a reminder, this webinar is aimed at those who are involved in the design and manufacture of charging points, charge point operators, suppliers to the EV industry, for example, those that might manufacture cables or sockets, and also OEMs. And I know we had some vehicle manufacturers register, so that's great to see interest from that sector as well. We did do a webinar yesterday, which was aimed more at procurers and commissioners and site owners. And that webinar will also be available via our website. So if you're interested in seeing that. Yesterday, the difference was that we looked more broadly at the design guidance, whereas today there'll be more of a focus on the products that we've designed ourselves, and some design examples of charging unit. So what will we cover in this webinar today? We'll start off with why you should consider accessibility, why it's important, not just for us, but for everybody. How we developed our design guidance, the process we went through, very much with disabled people at the centre of that design and development process. How this design guidance and the work we've done relates to the British standard that Jack mentioned. Some of you may know of that, so that's PAS 1899, and I'll touch on that shortly. Then the main part of the webinar will be for us to share some design examples of how we feel charge points could be made more accessible. We'll then touch on some other aspects of our design guidance around signage and information in the built environment, and point you at some other useful resources which you can find on that website. Then towards the end, we might suggest what you might do next after this webinar to move towards designing and developing accessible chargers. And as Jack said, there'll be plenty of time at the end for your questions. So, why consider accessibility? So we've been working in partnership with Motability on this work for almost 2 years now. And Motability, prior to us working with them, had done some research in this area with Ricardo Engineering Consultancy and with RIDC, the Research Institute for Disabled Consumers. And the Ricardo research identified that there'll be almost 3 million disabled drivers or passengers in the UK by 2035. And approximately half of those will be partially or fully reliant on public EV charging. So the focus of this work has been on public EV charging rather than charging at home. And that people may need to use public charging if they're on longer journeys and they need to charge en route, but often because they don't have facilities at home to charge and they may live in a flat, they may not have off-street parking. So really important for that group. And by 2035, although Motability scheme customers don't make up all disabled motorists in the UK, over 600,000 of their customers will be using EVs because of the ban on fossil fuel vehicles by 2030. So really important to state that. And so as a group, disabled drivers will be not the first to EVs, but will be a significant portion of EV users in the near future. And what the work by RIDC identified, which we built on, is there's currently a lack of accessibility across public EV charging infrastructure. And accessibility is also important because it doesn't just benefit those with greater access needs in general. If we can design and make products better for those that have greater needs, we also improve the experience for all. And it's also worth noting at this point that if we design and consider accessibility early, there isn't necessarily any increased cost in terms of the actual delivery of the product. So just to pause on the vision for this work, Motability's vision, which is shared by ourselves as a charity that represent disabled people, is that no one should be left behind in this transition to electric vehicles, and that we need to act now to ensure that EV charging infrastructure is future-proofed and meets the needs of disabled people in the future. And just to give some idea of where we are, there's estimates that we'll need roughly 300 EV charging points or connections in the UK, and we're currently, I think this data that came out at the end of last year was that we're at 37,000, so just over 10% of what we need. So there's an opportunity to act now and have a really significant influence on what's to come, and then also to look at some of that legacy infrastructure that might not be accessible and improve that as well. So in a really good position to actually achieve accessibility across the network. So how have we worked on this project, and how has this design guidance developed? So we conducted practical research and design activities directly with disabled drivers and passengers in order for us to understand how charging infrastructure was currently failing disabled people, and then explore with them through a human-centered design process what accessible design solutions might look like, and then disseminate that through our design guidance to industry to start and to inspire and give an understanding of what accessibility might look like. In terms of the people that we work with and the Motability customers that we worked with, it was people with a range of different mobility needs. It's often common when people think about access, think about perhaps accessible parking, that you think of someone who's in a wheelchair. But actually it's much, much broader than that. People with mobility issues and issues affecting their strength and dexterity, stamina, some people that may be only using one upper limb through injury or through other reasons. It's also worth noting that we work with both seated and standing users, and that's important in the design of charge points. So not just those using manual electric wheelchairs, also people who are standing using walking aids like walking sticks, crutches, frames, and also people with prostheses who may not have any mobility aids. And we also work with disabled drivers that currently had EVs, so had an experience of charging already, but also people who were completely new to electric vehicle charging. It's really important to work with those that have some experience and can explore those challenges with us, but also people coming to it for the first time, which will be the case for many people as they start to transition towards electric vehicles. And just to then, for those of you not aware of a human-centered design process, how it worked on this project is we worked through 4 or 5 stages, where we spent some time early on looking at understanding some of the key challenges through direct user research, us upskilling ourselves and giving ourselves an understanding of what EV charging was, then worked through a phase of ideation or concept design, using sketching and early modeling to kind of come up with some ideas about how we could solve some of those challenges. And then those went through a process of iteration, taking those from sketches and models into 3D prototypes that we could test with disabled users, into what we'll demonstrate shortly, which was the realization of some charging unit prototypes, both for rapid and fast charging. So what's key to that process is that every step along the way, we are working with disabled people in some way to understand their needs and then to test solutions with them. Okay, so how does the work we've done relate to the British standard that we've mentioned, PAS 1899? This standard was launched in the UK in October last year, and it was sponsored by Motability and the Office for Zero Emissions Vehicles, who are a department of the government. And within that, and I encourage you to get hold of a copy, it's freely accessible, you don't have to pay for it. There are detailed requirements and recommendations for accessible charging across different types of settings, whether that's a charger in a car park or roadside charging, and also the different speeds and types of charging we see. For example, fast charging, which you may perform overnight, and rapid and even ultra rapid charging now that you're doing in a short space of time on perhaps longer journeys. Our design guidance covers the full spectrum of the charging experience, from what you might need to do before you arrive, to arriving at the charge point, accessing the charge point, so the parking space, and then also the charge point itself and how you use that, how you might start, stop, and pay for charging. So we provide practical guidance to help and give examples of how you may apply design principles to the design of charging products in order to meet the requirements of the standard. It's worth noting the standard is obviously more detailed in terms of its requirements and recommendations, and our design guidance is predominantly focusing on the charging process itself and the charging units, which we'll go on to talk about now. I'm going to hand over to Hazel at this point, who'll take you through the next section.
Okay, so I'm going to kick off looking at the design guidance itself. And there are three core areas. As Keir touched on, we divided our work into signage and information, built environment, and charging an electric vehicle. And it's this third area, charging an electric vehicle, where we're going to spend much of our time today. I'm going to touch on the others, but I think for this audience, it's really appropriate that we mainly look at the charging process itself. So to start then, looking at the process of charging an electric vehicle. So to start off, a couple of summary ideas. This first idea is a combination of making sure that every user can see, reach, and use every part of the charging unit. Sounds really basic, it's often overlooked, and it's a really good set of touch points. If you were to take one of these slides into a site survey with you, take this one. There's a lot more to it, there's a lot more on our site, but this is a real core. So people need to be able to see, so recognize and also be able to see every part. They need to be able to horizontally and vertically reach every part that they need to access, and they need to be able to use every part, and that might involve grip, certain actions. They might need to apply load, they might need to press buttons, and all of this applies to people who are seated or standing. So this is a really important one that's drawn together from all of the things that disabled people told us throughout the work. And touching briefly then as a broad brush idea of the big challenges with cables and connectors, some of the biggest key barriers to effective use of these charge points that have cables. The cable length, weight, and stiffness are things that we know are serious issues for people. And we know the industry is well aware of this. And the connector design, typically they don't necessarily allow for people who don't have a classic strong one-handed grip. So that's something that we've addressed as well, which we're going to come on to shortly. So we created two different types of charging unit prototype as part of this work. We created a large rapid charger unit to demonstrate some of our design examples, and we created some fast charge curbside post type chargers as well. So I'm going to hand back to Keir to start talking about the first of those two, which is the rapid charging unit example that we created.
Thanks, Hazel. Yeah, it's worth noting at this point, this is a prototype. It's freely available. There's no plans to commercialize this from ourselves. And in terms of its aesthetic, we had some requirements to fit it in a testing area to be able to transport it in a van around the country. So aesthetically, it's not as you might see a charge point when it's installed in the real world. However, in terms of its features, in terms of the height and location of certain features that we'll talk through, it is accurate and correct. So first of all, we'll talk about connector design. So as Hazel mentioned before, one of the things we found out from engaging with a variety of different disabled vehicle users, particularly those with low strength and dexterity, was that the conventional connectors in terms of a single grip were not necessarily very usable. And so what we developed here is what we call a looped handle. So this handle, as you can see by these 3 images, is able to be gripped in a number of different ways, whether that be with 2 hands, which someone might use if they need to pull something out of the vehicle and need an additional hand to provide some more force. Those people that might be taller, and so the image in the middle, someone's gripping it on the top, or a seated user who may access that from the rear. And even the consideration here was even that the core or the inside of that loop is large enough for someone to be able to pass a hand and maybe their forearm through. If they don't have a conventional grip, and we did come across some users that didn't have all the digits on their hands and weren't able to grip something fully, they can actually pass their forearm through that and actually use that to kind of maneuver and manipulate it. So an example here of just a different way of approaching the connector design. And it's also worth noting that, you know, within this has got the terminals in it and the cables in it from existing products. So we believe this is achievable as a market product. And then just in terms of holstering the connector, just a short GIF here that you should be able to see moving. Really important that it's just very easy to locate the connector back into the charging unit. So you can see here that the holster opening is very large and then has a slightly narrow bit below. So it just drops into there. One of the things we experience from existing chargers is sometimes that the holster being very stiff, requiring a lifting action initially, or a lot of force to get it out of the charging unit, which can mean that someone can't even get the charger out to begin charging. So just considerations around the design of the holster, where that's located. We then move on to look at cables and cable management. On our prototype, you would have seen from the earlier images, we had the cable supported from above on an arm that rotated round and had some rollers in it to get a bit more length. So some images here just showing that. We also chose to have the cable coming out of the top of the connector so that there wouldn't be any cable on the ground, which would cause a trip hazard. And so, yeah, just some illustrations, some considerations here of ways of managing that cable. Arguably in this image, it's very close to the unit, and it's obviously much further away. There's more cable to manage. But yeah, by supporting it from above, by having the cable come out the top of the connector, just ways of resolving some of those existing issues with cable management and cables trailing on the ground. As you can see on the next slide, with the image on the left-hand side, we also designed this in a way that within about 2 meters of the charge point, where the cable is supported from above, by using a counterbalance, the cable is actually fully supported, so the weight is fully supported. So this person on the left-hand side has taken out the holster and then has just let go of it, and it holds itself in space. So this was shown really beneficial for wheelchair users who may need to take the connector out of the holster, may need to re-maneuver their chair and use both hands to do that. But then the connector is still hanging there in space when they need to grab it and insert it into the vehicle. And then finally on cables, just addressing the issues around stiffness. We just go to the next slide. Thinking about improving flexibility. We know this is a challenge because the cables are full of copper, and that's really important to achieve the charging speeds. What we've looked at here as an idea, and this very much needs some development work to bring it to market, is how can we actually increase the flexibility of the cable near to the connector, where people need to maneuver that and bend that to get it into the vehicle. So as you can see on the image on the right hand side, we've just got that orange piece that's marked coming out the top of the connector, just showing how that section is more flexible just by using different materials around the cable. I know there's a movement in industry towards more flexible cables, and that's great to see. And this has implications both in tight spaces where you have to maneuver from the charge point to the vehicle, but also when the cable is at full reach and you have to rotate it perhaps through 90 degrees to get it into the car. So it's not just weight, the stiffness, flexibility is really key as well. I'm going to hand back to Hazel now, who talked through a couple more features that we developed on this rapid charging unit.
Thanks, Keir. So I'm just going to briefly describe some of the key aspects of the touchscreen interface that we've put on. Touchscreens aren't the only way forward, but the way that we've chosen to do this one includes a large clear screen. That sounds very straightforward. It's often not the case. The screen provides clear instructions, so layman's terms, very straightforward language, no jargon, and not ambiguous, and feedback to the user, so telling them if the action that they've been invited to do has been successful. We've got large, high contrast content, so by way of text, symbols, and buttons. The buttons on the screen in the top image, there's 2 square buttons, and then they're labeled A and B. One is yellow and one is white, and they are separated in space, so it's not, and they're large, so it's not easy to press the wrong one by accident if you're not very dexterous. Ideally, you would provide a choice of format or method. So in our instance, we had an optional set of spoken instructions you could switch on if you wanted to, but we're aware not everyone wants this, so it's about choice. And again, for types of payment as well, providing a choice of ways to do things is really helpful, because we know that the idea of something being accessible is not just a single solution. You can't just create a consensus that one answer is the way forward for people. So I think ideally in your designs, one of the key ideas is provide a choice where you can. And as part of the labeling that you may have noticed in the previous images of the rapid charging prototype, we had very large and high contrast labels to show which of the 2 connectors, because there were 2 connectors on this example, which of the 2 connectors was connected to A and which was connected to B. And in this case, they both had the same charging type, CCS2, with a symbol to show that, because people are often familiar with the look of the end of the connector, but not perhaps what it's called. And labeling them A and B is very simple. And that doesn't rely on literacy, for example. You can use color and symbols to distinguish between similar features. And it's really good practice to use text and symbols together, so you're not relying on one or the other, again, playing to people's strengths. So what I'm going to do is now start to take you through our other type of prototype, which was a fast charging unit prototype. So the sort of thing you might see on a post in a smaller car park or along a roadside. So looking first at the connector design, the standard type of connector is one that you need to hold with one hand in a single grip, and it's quite a smooth outer shape that you just grip your hand around the outside of. Based on what Keir was mentioning earlier, it's clear that plenty of people can't actually do a single grip with one hand that's going to be effective there. So we've added a loop in a similar kind of principle, but in a different orientation to on the rapid prototype. This allows people to use either 1 or 2 hands in different combinations to find it much easier to use this kind of connector. So you could actually loop your hand through. So what I'm going to do now is pass it over to Keir for the next part.
Thank you, Hazel. So yeah, then to look at the fast charge unit itself, one of the elements that you interact with the most, and on some fast charge units it might be the only bit that you interact with, is the socket. And we did a lot of work understanding what would be a usable height for both seated and standing users. That work fed into the British standard PAS 1899. So if you want specific dimensions, please go and look there. But ultimately, what can be achieved by considering just the height of where the socket is something that can be accessed by someone that's seated in a wheelchair, that may not be able to raise their arm very high, and also someone that's standing of tall stature, a height that they can still access without having to bend down too low. You can also see on this image that we've actually angled the socket up slightly, just to aid those that are slightly taller to be able to see that. So just angling it by 10 degrees from the work we did really helped for you to be able to see that socket. If we move then on to the next slide, there's a few slides here. So the other aspect of the socket is probably the key design feature on this fast charge unit is the socket cover. So as you may have seen in a previous image, the conventional cover is a sort of sprung down flap. And so what that means is that when you take your connector out and it's no longer used, it automatically springs down. And that protects the internals of the socket and the connection from from dust and water, from weather essentially. So it's important there are socket covers, but we know at the moment they are a significant barrier because of how they need to be operated to accessing the charger. So we looked at several solutions here, and this one one of the key reasons why they're inaccessible is because you really need two hands. There is fairly awkward ways of doing it with one hand and the connector, but ideally you use two hands, one to lift the flap and a second to insert. So we'll just go back onto the previous slide. Sorry, Jack. So this one here just has some internal sprung doors. So as you can see with the moving image on the right hand side, you just offer up the connector and then push it through those sprung doors to make the connection. So there's no need to operate and that cover at all. In the next example, approached it slightly differently. So on this one, we've got this curved lip that you can rest the connector on. And actually, it wasn't designed this way or for this benefit. What we found out through user testing was that having that curved lip enabled some people to actually just rest the connector there for a short time and actually help them to guide it into the socket. So what happens here is you apply some force downward, a fairly low force, and then it exposes the socket and you can insert that. And when you remove the connector, that slides back up to protect the socket. So again, able to be used with a single hand. And then if we look at the final example, there's one more example. Yeah, so this one, so this actually uses a sensor or a switch so that you can place your hand over it or the connector and the socket cover slides up. So it's contactless. And then you insert your connector. So 3 different ways there of achieving a socket cover that can be used with just a single hand. There might be, I'm sure there's many other ways of doing that. So these are just demonstrating some solutions to that requirement. These are prototypes. They would need some work to become full products. We'd be happy to explore that with anybody. But yeah, by no means are these the only ways of doing it. But what's important here is if we can allow the socket to be accessed with the use of just one hand, that's important in terms of achieving accessibility. If it requires 2 hands, that it will exclude some people. Okay, I'm going to hand back to Hazel at this point, who will talk you through the last few features of this fast charge unit.
Yeah, so just to wrap up the last couple of parts on this prototype then, we have a simple example. This could be done in many ways, but we've put an example on the side of the unit. It's a simple shape that's a hook that enables someone to prop their walking aids up against it. So it frees up an extra hand while they try and use the unit. And that's an example of a really simple change that can make a dramatic difference to someone's experience when they just don't have enough hands to do the things they need to do. The benefit, if you design it in a certain way, is you can also loop up some of the spare cable and hang it over the same hook. And that helps to keep the cable clean off the ground. This particularly matters for example, people who use wheelchairs, because the last thing you want to do is have a wet, dirty cable that's been lying about in the mud in a car park that you then have to put on your lap in order to free up your 2 hands as you wheel around your vehicle carrying the cable. So we can expect that some of this group of people we're talking about are going to have potentially a lot more cable contact with their clothing than the wider public. So that's a useful feature. And finally, looking at the simple display, we realised that typically this type of fast charge unit is not going to have a full screen on it, but there are still things that you can do, and we've got more examples of aspects on our website and the design guidance site that we suggest you go and look at. The key ideas that you need to convey, however you do it, are to let the user know what to do, what should they do, give them clear instructions. So in the image on the right, there's an instruction of how to start and stop charging. And it says, tap the card here to start and stop. And it's got a contactless symbol. So that's a clear instruction of what to do. You need to let people know whether they were successful in doing the action. So here we've got an example where it says, plugged in, and it's got a tick and it's got a symbol of a plugged in car. So you've got various different formats of ways of letting someone know that when they were asked to plug in, they successfully did. The other thing that you need to let them know is what is happening now, what's currently going on. So at the top of this screen, it's a little bit washed out, but at the top of the image here, we've got a ring light around the top of the charging unit, and it's currently green, which by standard convention means available. If it were to be actually charging, it would turn to blue. And if it wasn't working, it would be red. But a key example of letting people know what is currently happening so they can glance at the unit and know exactly what's currently happening. And so that concludes that whole section on charging an electric vehicle. So we're now going to briefly touch on the other two areas that we talked about right at the beginning, the other two areas that comprise our design guidance. So the first one of those is signage and information. It is unsurprising that people want to know something about charging points before they get to them. And for disabled people, it can be incredibly important, not just convenient. So someone said to us, for example, it's so frustrating when I can't tell if the charge point will be accessible when I get there. It makes me anxious about my journey. So there's important information people need to know. In terms of accessibility specifically, there's quite a long list of things people might feasibly want to know, but some of the most obvious ones include things like the parking space size. Can they actually get their vehicle into the space? Because if that's not possible, it's game over, no matter how good the charging unit design is. But we mustn't forget that actually there's a whole load of general stuff that everyone wants, that this group of disabled people also need. So is it the right charging type for the vehicle? Is it available and is it working? All the kinds of stuff that everyone needs as well. Then touching briefly on signage, there's two aspects to this. Navigation signage, firstly. So someone said to us, I hate it when I get to a car park entrance and it takes me ages to find the charge points. I think a lot of people have experienced that. It's annoying, it's inconvenient, but for some people it can actually make an enormous difference to their day. So once you've successfully used fantastic signage design to show people to the charging point, there's some key elements that people were so keen on to display clearly at the charging point. So who's entitled to use the space? Are there any restrictions or charges required? What kind of charging is available and how fast is it? How can you access the charging? So do you have to be part of a scheme or can you pay with contactless or through an app? And finally, one of the options you can provide is really simple instructions. It seems often the case that you get either many detailed instructions in very small print that are hard to follow or no information at all. There's definitely a happy medium and it's really quite a straightforward and cheap thing to improve accessibility. And I'm going to pass back to Keir just to wrap up on our built environment, which is the final section of our design guidance.
Thanks, Hazel. Just to note on this section, as I mentioned earlier, you will find detailed requirements within PAS 1899, but we just wanted to identify these here and just give an understanding of why space is important and what we found out through our work. So space around the vehicle, so a larger parking space. You will be familiar with disabled parking spaces or accessible parking spaces and the hatching to the sides and often to the rear of those in order to give people with disabilities who are using maybe a wheelchair or other walking aids like a frame or crutches enough space to get in and out of the vehicle. And I can't emphasize that one enough. One of the things I found out through this work was it's not just people that have larger mobility aids that need that space. It's people that need to open their door fully in order to maybe swing their legs out in order to then stand up. It might not be using any mobility aids at all. And also for people who need to transfer from the vehicle into a wheelchair, and even in some vehicles where there are side access devices like ramps or side lifts. This extra space is really important. So space beside the vehicle. And then also space at both ends of the vehicle. So this is something which we came across a lot in our work was, although there may have been space given to either side, which there is in a conventional disabled parking bay, and space at the back to perhaps get access to, as in this illustration, deploy a hoist or a ramp in the safety away from traffic in order to access a mobility device. That the space at the front of the vehicle was really important, so that you've got enough space once you've parked to actually get access to the charger. And I think this is the case for many chargers, whether there is additional access needs or not. And you'll see the illustration in the top right here. This is a diagram taken from the British Standard, just highlighting what is best practice if there's enough space, is to provide that protected space at the front of the vehicle between the charger and in order you to get to that charger and to access its functions, even if the charge point on your vehicle may be towards the rear. And then also looking at charging unit position and some of the aspects of the built environment. So quite often at the moment we see charge points, whether they're in parking bays or on roadside, they're installed on plinths or curbs, and there's reasons for that which I won't go into. And there's often protection between the parking space and the charge point itself, whether that be a bollard or a bump stop. These can be key obstructions if it's not considered where those bollards are placed and how far back that unit is positioned from the curb. You can see here in his illustrations that through poor positioning, someone using a walking frame on the left-hand side is having to reach at full extent, and they need to keep one hand on their walking frame. And actually, in this case, they weren't able to lift it from the charge point and then use it because they were fully extended. And the image in the middle, again, through the fact that there is a curb, no way for someone in a wheeled device to be able to transition from the surface they're on in the parking space to the curb. They can't actually reach the connector in order to unplug it, partly because of that curb, but also because it's set back and it's also mounted at right angles to the parking space. So again, illustration here from the British Standard, just giving some ideas about and some guidance and requirements about where you might position bollards or other protection, and how much space you need to provide in front of the charge point in order for someone to be able to access it, in this example, in a wheelchair, and be able to fully navigate and turn around. And then just looking more widely at the location and the environment around charge points. A few key things here. One of them is, if possible, to provide lighting and shelter. In fact, not if possible. Lighting is really essential, both on the charge point itself and in the area, in order for someone to safely navigate around that parking space and that charging space. And shelter, obviously, a benefit in terms of protecting people from the elements. And we're in the UK here. I know it's lovely and sunny today, but cold. But we've had lots and lots of rain. And so, for someone who has a disability that may take more time to get in and out of their vehicle, if they're transferring into a wheelchair, for example, and then take more time to access the charge point, they don't want to be doing that if they're in the rain and wind. So shelter and lighting, really important. We've said here no shrubs or trees, but if there are any in the vicinity, it's important that those are managed and you don't end up with a scenario where you have overgrown foliage which is presenting access to the charge point. Flat, smooth, hard ground. So gravel is a big no-no, particularly for people with wheeled devices. The charge point needs to be, the parking space needs to be as flat as possible as well. Level access is optimum, is kind of preferred, but if there's not level access, then close by, nearby, drop curbs or ramps to move from one surface to another. Again, there's guidance on this within the British Standard. And then thinking about the location of the charge point within the wider environment, if there are facilities nearby, ensuring that the access from the charge point to those facilities is level and there's ramps for wheeled users, but also that ideally the distance between those facilities and the charge point is as close as possible. So we saw many examples, particularly with supermarkets, where perhaps for other reasons, but a far away corner of the car park was chosen to install the charging infrastructure with inaccessible routes then to the supermarket itself. So really key considerations here. I know there's other organisations out there doing some really good work in this area, very much putting the safety of all charge point users at the forefront when looking at new installations. So in summary, in terms of what we've gone through today, and then we'll move on to some questions. We've given you an overview of why you should consider accessibility and why consider that now, based on the work that Motability have done in terms of looking at that data. And for us, any product that we're involved with designing needs to consider all users. That means disabled users. We've given you an understanding of how we develop the design guidance using that human-centered design approach, both in the development of that guidance, but also in the development of the charging unit examples that we've shown you. So engaging disabled people at every stage of that process. And yeah, the importance of engaging people with different range of needs. So really broad. Our user engagement report is available through the resources section on the website. It's very extensive, and that will give you a really good understanding of the real range of disabilities that we've worked with. And then we've given you demonstrated the charging unit prototypes. Again, there's a section on the website, some great videos of those in use. So go and have a look at those. I think there are two-minute videos for each unit. So you can get a really good understanding of what we believe is a more accessible solution by looking at those. And we've also touched on other areas of the design guidance in signage and information and the built environment, which again, the British standard gives more detail for particular settings. So I know I've mentioned it already. Yeah, go and look at the website if you haven't already. There's a lot more depth there in terms of the purpose of the work we've done, the scope, how we develop the guidance and how to use it. We've included what we call a basic section on there. So that gives, if you're new to EV charging, you're new to electric vehicles, which we were before we started this project, gives you an understanding about the types of vehicles and the adaptations that disabled people might have. Also, just an overview of the charging speeds and connectors, and also the types of mobility aids that disabled people might be using. Gives you an overview there. There are other organisations out there. I know ZapMap do some really good stuff, and they keep that really up to date. But yeah, there's some stuff on there just to give you an idea of those basic aspects. The full range of design guidance in the 3 sections that we've mentioned, and I've just highlighted here under resources, the page on our charging unit prototypes. If you want more detail on what we've presented today, that's all on that page. As I say, with some videos on there. And we've also got other resources there under the further reading section. And I believe, Jack, maybe you can answer it in Q&A, the webinars, recordings or links to those will be hosted in that resources section. Those will be uploaded shortly. And not to be missed, we're going to be disseminating some more work around these in the coming weeks, and this is a part of our work that I'm really proud of, that Hazel led. We've got some case studies. So these case studies are they are fictional stories, but they are very much inspired and informed by the work we did and all the people that we engaged with on this project, which was over 200 people, and they just highlight different scenarios and different types of journeys that people are making when they need to charge, and highlight, how getting accessibility right can really have a positive impact on those people's experience of charging. So yeah, watch out for some more dissemination. We've got some animations and videos coming of these soon. Okay, and this final slide for me before we get onto the Q&A. So what might you do next? I'm not going to say it again, but you can see the top bullet point. Raise awareness with your colleagues, share the guidance and point people towards the British standard, so anyone that you come across within the industry, people that you're working with. And yeah, if you are a procurer or commissioner listening, you didn't come to the webinar yesterday, or you are part of a design and engineering team, both either for a or even a CPO, charge point operator, incorporate links to design guidance. There's also a downloadable version you can get hold of into your tender documentation, into procurement process. PAS 1899 puts the emphasis of the onus of responsibility, is the correct way of wording it, on the procurer or the commissioner, so who we see as kind of top of that food chain, and we want that to filter down then in terms of them requiring of their charge point operators more accessible solutions, and then them asking their manufacturers, okay, we want to meet this standard, and them asking their suppliers and so on. So yeah, get hold of those resources, share them, use them. Yeah. And yeah, you can download design guidance as well. It's available as a PDF from the website. And if we just go on to the next slide, we also have a design book which focuses on the charging unit prototypes that we've demonstrated today. We have some surplus copies of this. We have them printed for the London EV show. So if you'd like a copy, you haven't already got one, just drop us an email with a postal address and we'll send one of those out to you. Okay, that's it from me. We're going to move into our Q&A. So I'll hand back to Jack at this point, who's going to host that. Thank you.
Thanks, Keir and Hazel. Yeah, so we've got a couple of questions in so far. So if you do have a question, do put it in the Q&A. So the first question that we have, some really good questions here. What do you see as the challenges to implementing accessible designs?
Great. Thanks, really good question. This came up yesterday as well, actually, in the other webinar. I think one of the biggest challenges, and I guess it's not about accessibility, is reliability, and we are seeing movements in this. So I think the kind of legacy products out there, there was all sorts of different products and all sorts of different technologies, and reliability was one of those issues. And yeah, so that would be one of them. I think there's been some queries around how much accessible charging do we need. That was a question that came up yesterday. So I think there's a challenge there in terms of understanding that. I think in an ideal world, every charger would be fully accessible, but a bit like with disabled parking, getting some understanding of how much provision may be enough is important. We don't know the answer to that. I don't think others we've spoken to have quite grasped that yet, because arguably, there may not be the space to provide or make every charge point fully accessible in terms of the space requirements. So that's a challenge. Have you got any ideas on this one, Hazel?
Yeah, I think one of the key issues around implementing anything that's accessible is perceived high cost. And I think the key is to work around the idea that isn't inevitable. There can be costs involved, but it's not inevitable. The sooner you build it in, the more cost effective it can be. So trying to retrofit anything to become accessible is difficult and expensive. We all know that retrofitting is the worst kind of fitting, anyone with any kind of background in this sort of thing. But yeah, it is possible to minimize these expensive sounding things by implementing early. Yeah,
I think if I didn't mention it earlier, some of what we presented today is not hopefully is not unfamiliar to the attendees. We've tried to look at the whole charging process, so even looking at things like straightforward labeling and really good user interface design. There's examples out there. What we experienced is that there wasn't necessarily lots of charge points that ticked every box, and so I think that's why when you think about some of the challenges, I think a lot of what we've demonstrated is very achievable through tweaks to what exists and through applying best practice. One of the biggest challenges we have at the moment is that if you are installing a charge point for many different vehicles, brands, there isn't any standardization on the vehicle end in terms of where the charging socket is. And so that means that procurers are saying to us, well, we need to provide a 5 meter, we need to ask for a 5 meter cable, and we need that provided because it needs to get down to the back of the vehicle if someone has to park nose in and then get access to the rear of the vehicle, for example, the boot. So yeah, I'd love to speak to vehicle manufacturers, and I think if we look at the whole charging experience, and I always use Tesla as a good example, is that with Tesla, with their supercharger model, they did own the parking space, they did design the parking space, they did design the charger, they did design the interface in the vehicle, so they designed the whole system, and therefore Arguably, that you have to reverse a Tesla in because the charge point is at the back, and so therefore that can inhibit access. But that's just a question of space. They can provide more space, but because of that, the location of the charge point and the socket on the vehicle, they have a very short cable, which means it's lighter, and so there's that close proximity between charge point and socket on the vehicle. And then with our design examples, we looked at, because we knew that we couldn't solve supporting the cable. Well, we could, but it'd be very, very expensive, 5 meters away from the charge point. So looked at, okay, what can we do within a 2 meter radius to support that cable, with the view that ideally in the future we have a scenario whereby the socket on the vehicle is standardized, or there may even be more than one, so that someone can park with that socket close to the charge point. So yeah, there's definitely a challenge with the vehicles at the moment.
Thanks very much, both. A question from Richard. Thanks, Richard, for your question. With regards to curbside parking spaces, I understand the need for users to be able to reach the charger from the carriageway level, but clearance is needed from the edge of the curb to ensure that the equipment and signage don't get damaged when the vehicles pull away from the bay. Traditionally, we use 450 millimeters or 300 millimeters. So what would you recommend?
I believe there's some guidance on this within the British standard. It is something that came up within the steering group in terms of the highway regulations and requirements to protect from passing vehicles. So yeah, and there are different recommendations, I believe, in the standard. So I would point you towards that. But if off the top of my head, if I remember what was a feasible kind of reach distance for someone that's seated, if they're obstructed by a curb, it was definitely nearer 300 than 450. Yes. 450 becomes a much longer reach. So if 300 is achievable, that's going to make it much more usable. If not, you're looking at some sort of drop curves. So they have to come out and get up onto the curb in order to connect. But yeah, have a look at the standard for that, because I don't want to misrepresent what's in there.
I would also add to that it's worth giving serious consideration to whether you can come up with innovative solutions about how else you might prevent damage to equipment other than sighting them back. Because we know that we need to prevent damage, but we also know that some of those directly affect accessibility. So it's about trying to come up with something interesting and innovative that will do the same job, but doesn't actually conflict with the access needs that people have. And again, this always comes back to us saying, what you're going to need to do is really try this out with people. So I think the answer is try and stand back and innovate, but where you can reduce that distance as much as possible. But definitely, if there's a range, go for the smallest part of the range that you feasibly can. But ideally, start to look at wider solutions to that too.
Just had something to add at this point, unless we've got other questions, Jack.
We don't have any more questions currently.
Okay. When I talked earlier about technology and reliability, one of where we're at the moment is that there are multiple steps to activating a charger. And as an EV user myself, it's the most frustrating bit. I don't have any access needs, so the access is fine for me, but going through those steps and it not working, getting it wrong is a real pain. We know of something that we call, and I think the industry call, plug and charge. So the idea that in the future you are able to arrive at a charge point, it knows your vehicle, it knows you, you're registered, and you plug it in and it gives you energy, a bit like you being connected to the grid at home. You have someone that you pay every month, but you don't have to activate a card unless you have maybe a pay meter. And so yeah, plug and charge. And I actually came across today, so FastNed, who are fairly new to us in the UK, I believe, they have something they call auto charge, which has been out for a while. I think maybe Tesla have it as well. So that is actually through, I don't know how they do it, whether it's proximity or what, or something on your phone, but they've enabled that so that it's just reducing those steps. So they've done a lovely little video saying, when you get your phone at home or anything else, you plug it in and you just expect it to charge. Auto charge, I think they call it, allows the same thing. So that if we can move towards those kind of technologies we can as long as they're reliable, we can remove some of those steps that sometimes fall down and sometimes confuse people, and just make that process as simple as possible.
Another question from Richard, thank you. Another question, have you considered how your signage proposals align with the traffic signs regulations?
So I can take that if you like. Keir, feel free if you'd rather start.
No, that's fine.
So the what we've provided is a distilled version of all the things that we know people need. We haven't written it in conjunction with the traffic sign regulations. So if you've got any direct queries about that, you're welcome to come back to us in detail. But the signage proposals, we don't say specifically what wording, we don't say specifically, and I don't think the PAS mentions specific wording that you should use, but it's about conveying those really key ideas in a really clear way. So you obviously on private land where you're off-road, I think this doesn't apply, but there's lots of good practice in there. I think we've all probably seen motorway service signage that's less clear than we might hope, given how good the on-street traffic signs are in terms of their clarity. So I would say you want to combine all of the clarity that you get from the traffic signs regulations and make sure that you take on board all of the things that we've drawn directly from what people say. So the simplicity of making sure it's clear who is entitled to use a space, and if there's any penalty for doing so, and all of the details that we talked about before, just that real clear information that people need to know. So if you will have heard us say this before, if you go and look on our website, we've and in the documentation that we provide, and particularly our user engagement report that you can find through the website as well, that gives a lot of information. It gives you the clarity of why people told us those things in particular and the effect that it has on them. So I would say we haven't tried to develop a new set of signage regulations, but we've certainly got a good idea of what people need and that it must be clear and in the right place.
Thank you, Hazel. And we're reaching the end of our webinar now, so I'm just going to take us to the last slide. So thank you very much for making the time to join us today. It's really very much appreciated by us. If you have any further questions, here's the link to our website, and please use the contact us page to get in contact with us if you have any further queries. Just a reminder that we're going to be sending you a link to these slides and to the recording of this webinar. We're going to email those to you either later on today or tomorrow, hopefully. As you leave this webinar, there will be a short survey, and we'd very much appreciate it if you could complete that for us. That would really help us, certainly in particular with future events. So that would be great. Thank you if you're able to do that. And lastly, to say thank you once again for your time and your interest. And we hope that you feel encouraged that you can be part of this move to include everyone in public EV charging.